top of page 3 now for section 2.1. Same instructions that we've had so far. Solve each equation, use the addition property of equality. They're just highlighting this one concept right now in the book, that what you add to one side of an equation, you must add to the other. So they call it the addition property of equality. We translated that to our critical rule. What you do to one side of the equal sign, you have to do to the other. Okay. So as you move along in section 1 here, the problems do start to step it up a little. Okay, but if we follow our steps, we're going to be able to make it through these no problem. Okay, so let's start at 46. We're going to do 2 of these together, a third one in the next video, and then you'll have a couple tries to choose from at the bottom of the page. So on number 46, let's read it here. Negative 3x minus 5 plus 4x equals 9. As you're going along through the assignment and you hit this type of problem and you go, oh, this looks different, I'm not sure I know what to do. Before you panic or start making up new math, take a moment and go, wait a minute, what is different? What's causing me to be a little bit startled by this? What's causing me to hesitate before I jump in with what I've been doing? And the answer is probably the fact that there's 2 different x's, okay? Then, once you recognize what the difference is, relax and still apply the steps you've been practicing all along. Here's your chance. Now that the problems are getting a little bit unexpected, okay, it's not what you expected to see on the paper, trust the process, trust the steps. Our goal is still the same. Our goal is to get x all by itself on one side of the equation, isolated, because then we'll have a numerical answer on the other side. We'll have solved the mystery. We'll find out what x is. Okay, the steps here, we're going to do it just like we've done before. The very first thing we're going to check for is parentheses on either side of the equal sign that we need to simplify and remove, either using distribution or whatever. And there are no grouping symbols on either side of the equal sign. So that's done for us. Then we look for like terms. As we look on the right side of the equal sign, it's just plain old 9, nothing to combine. But as we look on the left side, and we'd already noticed this, there were 2 x's. So there are like terms here. We've got a negative 3x and a positive 4x here. So yes, there are like terms that we have to combine. So we're going to go ahead and do that. Negative 3x plus the positive 4x. I know it's positive because there's no sign in front of it. It's being added, so I'm free to move things around because of the plus sign here. So I add those together. Negative 3x plus 4x is going to be a positive 1x, or just x. And now I can rewrite my equation as just x, still have the minus 5, equal to 9. Okay, so the negative 3x and the 4x became x, and then I bring down everything else. I still have the negative 5. I still have the equal sign. I still have the 9. All I've done is combine the like terms. Okay. The next thing I check for is I pick a side. Is x on one side or the other? And yes, indeed, it's only on the left side, so that's been done for us. So it was almost like going through the drive-thru. Maybe this was more like stopping by the deli at the grocery store on the way home. You had to get out of your car, you had to go and place the order, you know, but it's still a lot less work than going home and making dinner from scratch. We won't comment on health, the healthiness of it, but we're talking about efficiency and ease here and just diving right into eating the meal. In this case, we're diving right into solving the equation with just a little bit of stop at the deli to combine like terms. All right. Next, we ask ourselves, what is happening to x? So we look at the side that x is on. Imagine putting a number in for x and saying what would happen next. And what would happen is we would subtract 5. There's only one thing that's happening to x, and that is that we would subtract 5. That's going to be typical of this section. There's just going to be that one thing happening to x. If you wanted to write it more visually, this is a verbal, written out version of it, subtract 5. Or you could do it more visual, where you'd say x, you have x, and then you subtract 5 from it, and you would read that from left to right. Now, once you've done the list, now you're going to undo that. This is now creating for yourself a foolproof list that you will follow to solve the equation. No more wondering, what do I do? what's happening, okay? We would go up the list here. There's only one step, so it's just a single list here. But if there were more than one step, you would travel up and change everything to the opposite. So instead of subtract, it would be add. We wrote the visual version here with the letters and numbers from left to right. We'll go backwards, right to left, as we go through this list. And the first thing we come across is -5. We'll change that to the opposite, +5. Either way, you're telling yourself, hey, what you need to do is add 5 to both sides. So we do that. And the x drops down, the equal sign drops down. Sorry. And the -5 and the +5 cancel each other out. They add together to give you 0. That was the whole point. We were getting rid of what was happening there. 9 + 5 on the right side is 14. Now we have our answer and we need to check it. So we check it back in the original equation, the original. -3 times x minus 5 plus 4 times x, does that equal 9? So when I take my 14 and I plug it into both spots where x originally showed up, will I get that equal to the original 9? Okay. What it does by checking in the original is if you made in this case, an error combining like terms, what you solve for, you may have done all the rest of the algebra correct and got an algebraically correct answer with the work you did, but it won't work back in the original equation because you made that initial rearranging error, that combining like terms. So that's why the check is important to have. And whether you do it on paper or in your head, that part doesn't matter to me so long as you're doing it, okay? It's a great way to catch yourself. Negative, and then you go through. -3 times 14 is a -42. We've got a -5 here, and then 4 plus 14 is going to be a plus 56. And we're still wondering if this is equal to 9. And -42 minus 5 is going to be a -47. Plus 56, does that equal 9? -47 plus 56 does give you a positive 9. This is a true statement. We have checked our answer. I am ready to put that in set notation. And my original answer was 14. Okay. All right, let's try one more together, and then in this video, and then we've got one that's going to involve all the steps we've been rehearsing as we go down here for the bottom of page 3, and then you'll get to choose between a couple different try problems. All right, so here we are. And if it catches you, when you first look at the problem and it kind of catches you by surprise or it causes you to hesitate, you aren't sure where to start, read it out loud. 4r minus 3 equals 5 plus 3r. Then ask yourself, what's so different that's causing me to hesitate? Well, could it be that there's r on both sides? Ah, something we've been training for. This is great. We're prepared for this. We've been checking to see if r is on one side or not. So trust the process, okay? We haven't done one like this before, but you can trust the process we've been training for all along, okay? The goal here is still the same. The goal is to get r all by itself. And we're going to start by saying, are there any parentheses, any groupings that we need to remove or get rid of on either side of the equal sign? And as you check both sides, that's already been done for us. We don't have to worry about it. Then we check on either side of the equal sign for like terms. So I check on the left, 4r minus 3. I check on the right, 5 plus 3r. And there's nothing to combine in terms of like terms on either side of the equal sign. That's important, okay? We'll deal with this double r situation in just a minute. Because our next thing to check for is r on one side or not? Okay, we get to pick a side for r. And it's on both sides of the equal sign. Here's the equal sign, we've got an r over here and an r over here. So the way we pick a side is we use opposite operations. It doesn't matter which one, okay? Some of you will get to a point where you know enough about who you are mathematically that you may want to try to avoid negatives. And so you rearrange it so you don't have to deal with a negative. Some of you will get to know yourself to the point where you go, I just feel more comfortable, I feel more confident when it's on the left side, and so you'll always move it to that side. Some of you will may apply another reason, or just mix it up, every other, or whatever your reasoning is, pick a side and then use opposite operations to get there. So in this case, I'm going to make the decision to put r on the left side. I've got 4 on the left, 3 on the right. For me, that avoids negatives, and that is usually my downfall. I tend to drop negatives. So I'm going to use the opposite operation. I see a plus in front of a 3r, so I'm going to use the opposite, and that's a minus. And what I do to one side, I have to do to the other. That's critical. Okay? It's the critical rule for solving equations. And then I take 4r minus 3r, that's just 1r or r. I bring down everything else. Minus 3 equals 5. And then the plus 3r minus 3r, they cancel each other out. They equal 0. That was the whole point. Okay, so now we've got one we're more familiar with, what many people refer to as a one-step solve to an equation. We're doing overkill here, looking at, okay, let's talk through this whole process. Many of you will have this solved even before you've got it written down. You'll see that the answer is going to be 8. But we're practicing the steps so we're ready for when they get harder. Here's the next step. We ask ourselves, what's happening to r? What is going on? Look at the left side of the equation and say, what if we put in a value for r? What would happen? Well, we'd have to start by subtracting 3. Is there anything else we're doing to it? No. So it's a one-step list. That's okay. They'll get longer as we go, and this method will make more sense. Or you could do more of a visual thing where we say, okay, we started with r, then we subtract 3. Sometimes it'll look like you're copying the equation. It won't always look like that. And what you need to remember is you're telling yourself from left to right what's happening to r. Then we go back through and reverse that list. So if we made a list going 1, 2, 3, 4, 5 down here verbally, we would go travel back up that list and change all the operations to its opposite. So instead of subtract here, I would add. For the more visual look here, as we say we have r, then we subtracted 3, we'll go right to left now, back through that, and change everything. So instead of minus 3, it's going to be plus 3. Either way, you've told yourself, hey, this is what you do. So we'll do it. Plus 3 to both sides, that's critical. Bring everything else down. So the r comes down, the equals comes down. Negative 3 plus 3 is 0, that was the whole point. Meant to get rid of it. 5 plus 3 is 8. Take a moment to check our answer back in the original. Okay, very important. So 4 times r minus 3, will that equal 5 plus 3 times r? So I'm going to take my answer, plug it in both places, 8 and 8, and I'm asking myself, will this make a true statement? On the left side, I get 32 minus 3, which is going to give me 29. On the right side, I get 5 plus 24, that also gives me 29. So this is a true statement. I have checked it, and now I am good to write my answer in the set notation. The two little braces, I call them little French things. They're not French. They just seem fancy to me. 8 is our answer. Set notation. Okay. So that's what those are. It's like saying here, I want you to notice the answer that I've got. A little set notation. Okay, so we will try one more. They're starting to look more involved, but the steps are going to stay the same. You're actually going to find that you can do these with relative ease because we've been rehearsing all these steps. So meet me at the next video at the bottom of the page, and then we'll do one more example together. You'll get a couple tries to choose from.